Inverse Matrices, not starring Keanu Reeves.
Dude.
After an unfortunate drugstore accident tears a hole in the space-time continuum, Joel, the pharmacist's assistant, finds himself inside a matrix. Not the matrix, just a matrix.
Say what?
Specifically, a 2x2 matrix with the values 1, 3, -2, and -1. Suddenly, Joel, if you stay here too long, the hole in the space-time continuum will close, trapping you here forever. The only way to escape this matrix is to invert it. Once the matrix is inverted, you will fall back into your own dimension. Gotcha. How does Joel invert this matrix so he can get back to the right dimension? Well, first he tries turning the matrix upside down. That doesn't work. Next he tries reversing the order of the numbers. Nope. Let's help him out with some basics. There's a 3-step trick to finding the inverse of a 2x2 matrix. First, we find the determinant, which we can do with this formula. A times D minus B times C. We can see that A equals 1, B equals 3, C equals -2, and D equals -1. So plugging this into our determinant formula, we see that 1 times -1 minus 3 times -2 gives us -1 plus 6, or 5. The next step in finding the inverse is to switch the positions of A and D, and switch the signs of C and D. Positive becomes negative and vice versa. So if we look back to our matrix, A and D switch places. So the top left corner of the matrix becomes -1 and the bottom right corner becomes 1. Then we switch the signs of C and D. So 3 becomes -3 and -2 becomes +2. For the final step, take that mixed up matrix and multiply the whole thing by 1 over the determinant, which is 5. So we get 1/5 times the mixed up matrix to get -1 over 5, -3 over 5, 2 over 5, and 1 over 5. Inverse matrix achieved. Speaking of which, we should check on Joel. Back to your dimension, pharmacist. Off you go.